Okay, this is Friday. I think it's January what? 7th? 8th today. January 8th, and we're working on chapter 10.1 in your Math Links 8 chapter on algebra. We're solving linear equations is what the title of the chapter is. So we start at question 3. It says an unknown number is multiplied by 5, and the result is negative 45. It says, A, choose a variable. Now, of course, if it says an unknown number, typically we would use the variable what? X. But if it's an unknown number, what other variable would be appropriate? What other variable, excuse me? N. Now, even though all of you probably used X, I am going to use N only to say because it represents a number. So N represents the number, right? N represents the number. So therefore, write an equation to represent the situation. So if I multiply a number by 5, there are some people who have done this, N times 5. There are also some people who have done this, okay, a number multiplied by 5. Both of those answers from now on are going to be wrong. Those are not ways to express multiplying a number by 5. What we are going to do is we are going to multiply the number by 5 by using a 5 coefficient. And the coefficient's job is to multiply the variable by a number, in this case 5. The result is, or even just the word is a mathematical word for is equal to or is going to be or is negative 45. So the equation you should have constructed is either 5n equals negative 45 or 5x equals negative 45 or 5 any other variable equals negative 45. And then it says draw a picture to show how you might model a solution. So if we represent this to be an n, this is going to be that mystery number. We're going to use an algebra tile. If I take that, oops, and if I was to make that instead of one of them, I'm going to double it, triple it, quadruple it, quintuple it, or multiply it by 5. And I make a scale. Now the reason why we use a scale in modeling is to show you that both sides are equal. Right? That little fulcrum point there, that little triangle represents equality. And over here, I could draw negative 45, or if I wanted to, just put one negative down and say multiply that by 45. But if you wanted to, you could just draw 45 negative ones, but that would be ridiculous if you wanted to. The second question says Raj is solving the equation n over 9 equals negative 4. Now before we go to that, I want to make sure you all understand how to pronounce that. So if I ask people to read it, they would usually say n over 9. And that's not what it means. That's just how you would write it, right? That's what, if you were giving instructions to somebody of how to write that, you would say n over 9. But that's not what it means. It actually means a ninth of n, or n divided by 9. It means both of those instead. So if I said, what does it say? You would say a ninth of n, or n divided by 9, is negative 4. So if we look here, there is his expression, and what he chose to do was multiplied by negative 9. And he's doing that because he thinks that in grade 7, if you had n plus 2 equals 6, the way you got rid of a negative or a positive 2 was to put the opposite number there on both sides. And that worked, and you got n equals 4. But when you're getting rid of coefficients, and in this case a fractional coefficient of a ninth, you don't multiply by the opposite. You have to multiply by the actual number itself. So his mistake was he multiplied by the wrong number. He should have multiplied both sides by a positive 9, because that's what the fractional coefficient is. If you think about it, if you think about this here, a ninth of n, it's really a ninth of n, right? If you wanted to think of it that way, or if I wanted to change it to a decimal, I could. And if I draw it, and 1, 2, 3, 4, 5, 6, 7, 8, that's a ninth of n. The reason why we multiply it by 9, don't get tied into the opposite operation. Think of this picture right here. The reason why we multiply it by 9, is because if I was to multiply by 9, I'd get this picture, and each of these would then fill up one full n. I'd have one full variable, right? And that's the purpose. If you multiply it by -9, it doesn't make sense because you'd end up with a negative n value, which doesn't lend itself well to solving the equation. In question 7, it says solve by inspection. And when we solve by inspection, what I want you to do on a test is write two things. I want you to write a question, Q. And what this says is what number, that's what the J represents, what number multiplied by -8 is 64 question mark. So on your test, if I say solve by inspection, you'll get a point for that. And then you'll get a point for this, the answer. What number do you multiply by a negative number to end up with a positive? Well, you know that a negative times a negative is a positive. So I know my J has to be a negative value. And -8 times -8 is positive 64. Question for your next one is what number? What number times 5 is -25? Your answer again. So a positive 5 times a -5 is a -25. So your answer is -5. This one here, it says what number, so I'm going to actually read it backwards. What number divided by 3? What's another way I could say it? Instead of saying what number divided by 3 is -6 by -3 is, or sorry, 6 positive 3. What's another way I could say that? So an alternate way we could say that, as one student in the class pointed out, is a third of what number is -6. So if I think about a third of what number is -6, well, I know my answer has to be a negative value because a negative divided by a positive is negative, and the answer is -18. -18 divided by 3 is -6. Now, the last one becomes difficult to interpret, so I'm just going to say what number divided by -11 is -4 question mark. Now, another way you could say it is a -11th of what number is -4, but that would be confusing and not very productive. So we're going to say what number do you divide by -11 to get -4? And the answer is 44, a positive 44, because 44 divided by 11 is 4, and a positive divided by a negative is a negative. Question 9 and 10 are using your models, so I'm going to do it real quick. I'm going to get lazy here with my variables. Instead of doing the whole shaded in thing, I'm just going to put 2 negatives. So we have 2k's equals -8. And if 2k's have the weight of -8, then each of those k's, or variables, has a weight of -4, and our solution would be k equals -4. Over here, it says -3 is equal to, now here's where it's important. You have to be able to read this two different ways. You could say t divided by 4, but a much more appropriate way to write it would be a quarter of t. A quarter of t. And the reason why that's more appropriate is because if I think of that rectangle as being t, I only have a quarter of it, right? So I only have this much of t. I have a quarter of t. So -3 is equal to a quarter of t. Now, if I ask myself how many of those quarters do I need to make a full t, I would need 4 of them. And if I quadruple that side, in order to maintain equality, whatever was on the other side, I have to quadruple that as well. So what we end up having here for our final solution is these here are going to make a full x, or a full t. And over here, I'm going to have -12. So my solution is going to be t equals -12. And if I want to make sure my solution is correct, I can simply go back into my original equation and substitute the t for the -12 value. And is this true? -3 is equal to -12 divided by 4? It is, so therefore that is the correct solution. Question 10 says 3b equals -15. So again, I'm going to put 3 b's down, or variables. I could shade them in if you wanted to, but I'm not going to. Equals -15. That's our initial drawing. So these 3 b's are each going to have their own private scale. And then I'm going to divide these equally among those three scales. And I have the solution, b equals -5. Oops, I made b instead of d. And the final question I told you didn't have to do, but I'm going to show you anyway. So if the equation was this, you would draw a third of k is equal to -3, or x, excuse me. But because it's a negative third, it becomes very difficult to draw. So we don't usually draw it, because how do I make this a negative third? I'd have to make a little negative sign there, okay? And as a result, it doesn't lend itself well to modeling it. So for my purposes, I'm not going to make you model it. But if you can model the positive version, right? The negative version is simply the opposite of it, so we don't have to worry about it. We'll just keep it there. Question 11. Very easy question. It said, by what number would you multiply or divide both sides by? For A, you would multiply both sides by -3. For B, sorry, you wouldn't multiply. What are you doing? No, you wouldn't. You divide both sides by -3. Why didn't someone stop me? For B, you would divide both sides by -4 to get rid of this coefficient. Right? For this one, you would divide both sides by -9. And for this one, you would divide both sides by +4. Question 13, solve each equation using the opposite operation. So again, my coefficient is 4. So if I thought about that, it's 4 s's equals -12. And what we would do is we divide those into 4 scales. So here we're going to divide both sides by 4, just like we did here. And as a result, when you divide both sides by 4, oh, hang on, back, divide both sides by 4, you end up with s equals -3. For this one, my coefficient is -12, so I'm going to divide both sides by -12. And I'm going to get j, which is left by itself, and it doesn't matter which side you go on, and we're going to put it there, is equal to whatever 12 divided by 156 is. Now I know 12 divided by 12 is 144, and if I add 144 onto 12 onto 144, I get 156, so that's one more than 12. That means it's 13. Just working out the math in my head. Is it going to be a positive 13 or a negative 13? Positive, because a negative divided by a negative is a positive. All right, clean this up a bit. In C, I'm going to divide both sides by -4. Give me j equals, since there are 25 fours in 100, or 25 4 quarters in 100, then in 104 there must be 26 of them. Will that be a positive 26 or a negative 26? Negative, because a positive divided by a negative is a negative. And finally, the last one, divide both sides by -27, the coefficient. T will equal 27. There are, see, 2 of them would be 54, right? So 4 of them would be 108. And therefore T equals 4. Or if you get a little OCD with your orders, you can put T equals 4. All right, question 15, we have fractional coefficients. So here we're going to multiply this time both sides by -6. To give me G equals 60 and 18 is 78, -78. Oh, it just says what would we multiply by? Ooh, my bad. Well, that's an easier question now, isn't it? Multiply both sides by -6. Multiply both sides by 3. Sorry. I guess multiply both sides by -21. And finally, multiply both sides by 17. And notice how your z, when I make my z's, it looks like this. We were just talking about variables. Why? Because what does this look like if I didn't? A 2. So therefore, we put a line through it to differentiate between 2's. No, he's right. Make a little curly on it. Yeah. The next question, 17, actually asks you to solve it. So here we're going to multiply both sides by 3. And notice how I use just brackets. I mean, other teachers will let you use different things. For me, it's just brackets. T equals negative 36. Multiply both sides by negative 10. H will equal negative 120. Multiply both sides by negative 7. S will equal 70 and 35 is 105, negative 105. And question D, multiply both sides by negative 9. X will equal 540 and 27 is 567. Positive 567. Question 27 is a story problem. It says, Nakasuk's snowmobile can travel 13 kilometers on a liter of gas. He is going to visit his aunt in a community 312 kilometers away. Nakasuk wants to know how many liters of gas he needs to travel to his aunt's community. So with story problems, we're going to have a standard way an expectation for solving story problems, especially when we're utilizing algebra. So it says write the equation in this form. Now this form A represents a coefficient multiplied by the variable equals a value, right? A is your coefficient, X is your variable, B is your equivalent value. So it tells you what style to write it in, and this is while we're getting used to it, and then eventually it takes that training wheel off your story problems, and you have to know that's the style you need to write it in. But the first thing we're going to always do, the first step is define your variable. You need to tell yourself and figure out for yourself what is the variable X going to represent in this equation. So I'm going to say X will represent, and here's how you normally would do it. If you read the last sentence and you're looking for what you're looking for, you want to know how many liters of gas. 97% of the time in these basic questions as you're getting used to it, X will represent the number of liters he needs. Okay? So the very first thing you're going to get a point for on your test is defining what the variable will represent, not what the answer is. That's a completely different thing. You just want to define what it's going to represent so that when you get the answer, you know what it's representing. Now, the second thing we need to do is figure out what is our equation. So each of those liters allows him to travel 13 kilometers. So if he only had 1 liter of gas, he could only travel 13 kilometers because it has 13 kilometers on 1 liter of gas. So if he had 2 liters of gas, he could travel 26, etc., etc. So what you are really doing is you're taking the liters of gas, and for every liter, you're multiplying it by 13 because every liter of gas will allow you to go 13 kilometers. So because you're multiplying how many liters of gas by 13 to figure out how much distance, we are going to make that the algebraic expression 13 multiplied by x, right? 13x. We have a coefficient of 13 because every liter of gas will allow you to travel 13 kilometers. And that has to be equal to the distance he needs to travel. So the equation we need to create here is 13 multiplied by the number of liters will equal 312 kilometers. And once we have that, for B, all we have to do is solve it by using opposite operations. So we have a coefficient of 13. So if I divide both sides by 13, I will isolate my variable x. And if I use my calculator, 312 divided by 13 equals 24. Right? And the final thing we need to do is write a sentence. So now we have it. We go back to what we defined our variable as, x equals number of liters, and we say, therefore, he will need 24 liters of gas. Question 21 says, for the month of January, the average afternoon temperature in Calgary is a quarter of the average morning temperature. So if we think about, this is a thermometer, right? And this is the afternoon temperature. And this is the morning. This is 0 degrees here. whatever it happens to be, morning, morning. So the afternoon temperature is a quarter of the morning temperature. The afternoon temperature is a quarter of the morning temperature. So the morning temperature is much colder than the afternoon temperature. So it says the average afternoon temperature is -4 degrees. So if I write this down here, the average afternoon temperature is -4 degrees. What would the morning temperature? You could probably solve this by inspection, couldn't you? Right? But what we're saying is, what's the definition going to be? X is going to represent the afternoon. Sorry. What is the average morning temperature? Sorry, the morning temperature. The X is going to represent the morning temperature. All right, the morning temperature. So if I think about a quarter of the morning temperature, now we talked about that already, a quarter of the morning temperature. Taking that morning temperature and making a quarter of it, there are three different ways. We could do a quarter of X, we could do a quarter of X, or we could do a quarter of X. With those three methods, the one that we're most familiar with in grade 7 is the first one. So we're going to represent a quarter of the morning temperature with taking that X, or that morning temperature, and dividing it by 4. And a quarter of that is equal to the afternoon temperature. Right? A quarter of the morning is equal to the afternoon. And since we know the afternoon temperature to be -4, our equation will be a quarter of the morning temperature is equal to the afternoon temperature, which is -4. Once we have that, we're going to multiply both sides by 4. And we get X equals -16. Right? -4 times 4. And I can even put that on my thermometer right now. So if the afternoon temperature is a quarter of what the morning temperature was, that makes sense. And therefore, the morning, the AM temp was 16 degrees Celsius. Question 23 says the height of a great owl is 5 times the height of a pygmy owl. A great owl can grow to be 85 centimeters tall. Model this problem. So before I even start, one of the things we talked about before was using a picture to help you solve. So if I was to make a scale, and I was to put the great owl here, and I was to put the pygmy owl here, I know that those are not equal. In fact, if I was to draw it properly, I would have to have it like this. The great owl's here, because he's heavier, and the pygmy owl is here. So my job in this equation is to figure out, how do I go from this to this? I want to make it balanced. I want to make both sides equal. So the great owl is 85 centimeters tall. The pygmy owl is much shorter. So since this is 5 times bigger than this, if I was to take this pygmy owl, his weight, or his height, excuse me, not his weight, and multiply it by 5, I would finally end up with this great owl and the pygmy owl. If I was to multiply the pygmy by 5, this height. So, with that said, X is going to represent the pygmy's height because we're looking for it. And therefore, if I take the pygmy's height and multiply it by 5, I will have the exact same height as the great owl. So my equation will be 5x equals 85. Divide both sides by 5. Now, since I know there's 25s and 100, then there's 3 less than 85. My answer is going to be 17. My final answer will be, what's the height of the pygmy owl? Therefore, the pygmy owl is 17 centimeters tall. And your last question says, Kim works at an art gallery. An art dealer offers her a sculpture for $36,000. The dealer says that the current value of the sculpture is twice its value in the previous year. What was the value of the previous year? So X is going to represent, since it's my question, the value last year. Right? The value last year. So if I think about this again, last year versus this year. Last year was less. Sorry, I got that backwards, don't I? Let's reverse my scale. This year is this year is more than last year. Okay, this year is more than last year. So if I say the value last year is X, if I wanted to double that, so I'm going to take last year's value and double it, that will be equal to, if I double this side here, I'm going to create equality because last year's was half as much. So I'm going to put $36,000. There's my equation. Very simple grade 7 equation. X will equal $18,000. So therefore, last year's value was $18,000. Now, if the value of the sculpture increases at the same rate for next year, what will next year's value be? Okay, so this year is $36,000. So if I think about this year's value, what will it be in relation to next year's value? What will this year's value be in relation to next year's value? Will this year's value be twice as much as next year's value? No. This year's value will be half as much as next year's, because next year's going to double, right? So this year's value is half of next year's value. If I write that sentence out, this year's value will be half as next year's value, and I say X is equal to next year's value, this year's value is half of next year's value. What is next year's value? So because I'm saying what is next year's value, I'm going to make X represent next year's value. Okay. Do I know this year's value or next year's value? Which one do I know? This year's is how much? $18,000. And if I say this year's value, so if next year's value is X, how do I get this year's value and next year's value to be? If X is next year's value, I have to divide it by 2 in order to get it to equal this year's value. Agreed? Because it's going to be twice as much, I have to cut it in half to make it equal to this year's. And because I do that, when I isolate the variable, I'll end up with next year's value will be $30,000 because I have to take the value of next year, cut it in half to find, and I already know what this year's value is. So my answer is $36,000. Oops, I made a mistake. It wasn't supposed to be 18,000 here. It's supposed to be 36,000, wasn't it? Sorry, 36,000 here. And if I double it, I get $72,000. My fault. I was using the number that I only saw on the board. So therefore, next year's value will be $72,000.